Hi class. In this video, we'll be talking about separable equations. So I'm going to start with number 4 here. Y prime equals y times the arctangent of x. And the idea is to first find the constant solutions and then find the non-constant solutions by separating variables. To find the constant solutions, we set the function of y on the right-hand side equal to 0. In this case, it's actually really easy because the function of y is just y. So setting y equals 0 yields the constant solution y of t is identically 0, or y of x rather is identically 0. Okay, having found the solution, we move on to non-constant solutions. And this requires integration typically. The first step is to separate our variables. Which is to say, get all of the y's on one side and all of the x's on the other. This is possible because the equation is separable. Next, we integrate with respect to x. Now, it looks like the left-hand side is going to be tricky, but it's actually not terrible if we note that y prime of x dx is the differential dy. So I'm going to say note dy is y prime of x dx. Then the left-hand side simplifies into dy over y equals, well, okay, well, so now we still have arctangent of x dx on the right-hand side, but it's okay. Integrating the left-hand side yields natural log of the absolute value of y. And to integrate the right-hand side, we're going to have to use integration by parts, where dv is the most complicated thing that we can integrate. In this case rather, it's dx. So u is arctan of x, dv is dx, du is 1 over 1 plus x squared dx, and v is x. So we get x arctangent of x minus integral x over 1 plus x squared dx. And now this is a substitution. U tilde equals 1 plus x squared. Du tilde is 2x dx. So we get minus 1/2 integral du tilde over u tilde, which is x arctan x minus 1/2 log of absolute value of u tilde plus c. Getting back to the x variable, yields 1 plus x squared here. So our solution is the natural log of the absolute value of y equals x arctan x minus 1/2 log of 1 plus x squared plus c. You may briefly wonder why I didn't put absolute values around 1 plus x squared. The reason for that is simply that it's always positive. I could try to solve for y here, but it's completely unnecessary. In general, you won't be able to solve for y, so we just leave it as an implicitly defined function. So we have two classes of solutions. We have our non-constant solutions, which come from the separation of variables and integration, and our constant solutions. You need both of these for your solution to be complete. Okay, let's try another one. We're going to try number 7, which is y prime equals the square root of 1 minus x squared times the square root of 1 minus y squared. again, we're going to break our solution into two pieces. The constant solution, these are always the one that you should do first. We set the function of y on the right-hand side equal to 0 and solve for y. Well, to do this, we need to square everything. Fortunately, 0 squared is still 0. And now I can factor the left-hand side. And we can see that y equals 1 or negative 1. Both of these are constant solutions. So I'm going to go ahead and put a box around those. That part of my solution is done. Next, the non-constant solutions. I separate variables. I get y prime over the square root of 1 minus y squared equals the square root of 1 minus x squared. And again, I integrate both sides with respect to x. And use the fact that dy is y prime of x dx. So the left-hand side can be written as dy over the square root of 1 minus y squared. And the right-hand side is still just the square root of 1 minus x squared dx. Now on the left, we could do this via trig substitution or recognize that this is the derivative of arcsine of y. And on the right, we're going to have to do a trig substitution. There's just nothing for it. So this is a sign substitution because I have a constant minus the variable squared. So I'm going to let x equal sine theta, and dx is cosine theta d theta. And plugging this in, I get the square root of 1 minus sine squared theta times cosine theta d theta. And simplifying this, 1 minus sine squared via the Pythagorean theorem is cosine squared. If I take the square root of cosine squared, I'm just left with cosine. Since I have another cosine there, it's cosine theta from this term and then cosine theta from this term. So cosine squared theta d theta. Actually, let me write this a little bit neater. Now, what we can do is, we have cosine squared. We may think to do the Pythagorean theorem here, except we're going to get right back to 1 minus sine squared, which is virtually the same integral. Instead, we're going to integrate this thing by parts 2 times and use the so-called add-over trick. So I'm going to write this as an auxiliary calculation. If I let u equal cosine theta and dv equal cosine theta d theta, which is this most complicated thing that I know how to integrate, and v should be sine of theta, and du is negative sine theta d theta. Using the integration by parts formula, I'll get sine theta cosine theta minus, and I'll get sine squared, but it's negative, so I'll get a plus here, d theta. And now I can use the Pythagorean theorem. To leave me with an easy integral, the integral of d theta, minus the integral that I started with. So the integral of d theta is just theta, minus integral, and this was going to be cosine theta squared, again. This is what I like to call the add-over trick. We have this integral equals some horrible stuff out front minus the same integral. Therefore, if we add this integral over to both sides, that's why I call it the add-over trick. I just get this expression. And so, if I just divide by 2 and add my constant of integration, I get the integral in question. So that tells me that the solution, so this is the end of my auxiliary calculation, that my solution is arc sine of y equals, so arc sine of y equals, oh no, how do I get back from thetas to x's? Well, I simply draw this triangle. I want to draw theta, and I know the sine of theta is the opposite over hypotenuse, and that's supposed to be x over 1. So opposite over hypotenuse is x over 1, and this leaves me with the square root of 1 minus x squared along the adjacent side from the Pythagorean theorem. And so I can say that this should be arc sine of x plus the sine of theta is x. The cosine is the square root of 1 minus x squared, all of which is divided by 2, and then I add my constant. And there we go. So typically there are two main sticking points in these separable equations. The first is simply remembering to do the constant solutions. Oh, so I should underline. I'll use orange. After we remember to do the constant solutions, the second part is just integration. And the tricky part is actually remembering all of your integration techniques.